Hi everyone, I am Priyadarshini from EC department. I have case study topic on validate the applications of gyroscope in aerodynamics. Gyroscope. What is gyroscope? A gyroscope is defined as the device has a spinning disc that is mounted on the base such that it can move freely in more than one direction. So that the orientation is maintained irrespective of the momentum in the base. This is the gyroscope diagram. Gyroscope have wheel axis, inner gimbal, inner pivot, outer pivot base. These are all the gyroscope parts. Types of gyroscope. The following are the three types of gyroscopes: mechanical gyroscope, optical gyroscope, gas bearing gyroscope. Design of gyroscope. A gyroscope can be considered as a massive radar that is fixed on the supporting wings known as the gimbals. The central radar is isolated from the external torques with the help of frictionless bearings that are present in the gimbals. The spin axis is defined by the axle of the spinning wheel. The radar has exponential stability at thin speeds as it maintains the high speed rotational axis at the central rod. The radar has 3 degrees of rotational freedom. Gyroscope working principle. The working principle of gyroscope is based on gravity and it explained as the product of angular momentum which is experienced by the torque on a disc to produce a gyroscope position in the spinning wheel. This process is termed gyroscopic motion or gyroscopic force, and it is defined as the tendency of a rotating object to maintain the orientation of its rotation. We know that the rotating object possesses angular momentum and this needs to be conserved. This is done because when there is any change in the axis of rotation, there will be a change in the orientation which changes the angular momentum. Therefore, it can be said the working principle of gyroscope is based on the convention of angular momentum. Applications of gyroscope in aerodynamics. Gyroscope flights instruments are instruments which have a mechanical gyroscope incorporated into their design. Gyroscopic flight instruments of some description are used in most general aviation aircraft and in older commercial aircraft. Examples of such instruments include attitude indicators, heading indicators, and coordinators, turn and slip indicator. The gyroscopes within the instruments are usually electrically or vacuum driven and make use of the basic gyroscope principles to display the attitude of the aircraft. In more modern installations, mechanical gyroscopes have been replaced by laser gyroscope. The principal characteristic of a gyroscope which makes it suitable for use in attitude instruments in rigidity in space. A secondary gyroscope principle which must be understood and compensated for as necessary in precision. Rigidity in space. The primary trade of a spinning gyroscope radar is rigidity in space, otherwise known as gyroscopic inertia. As stated in Newton's first law, a body in motion tends to move in a constant speed and direction used unless acted up on by an external force. The spinning radar inside a gyroscopic instrument maintains a constant attitude in space as so long as no external forces act to change its motion. This stability will increases in proportion to any increase in mass of speed or of the radar. As a consequence, the radars in gyroscopic aircraft instruments are constructed of heavy materials and are designed to spin at rates in the order of 10,000 to 15,000 revolutions per minute (rpm). Attitude and heading indicators use gyroscope as an unchanging reference in space. That is, once the radar is spinning, it maintains a constant position with respect to the horizon or the direction. The radar of a universally mounted gyro remains in the same position even as the surrounding circular frames or gimbals are moved. For all intents, this allows the aircraft to rotate around the gyro without unchanging the position of the radar. The aircraft attitude or heading can thus be compared to the radar to enable the instrument to display the actual attitude or direction. Precision is the dating or turning other of the radar axis as or a result of external forces. When a deflective force is applied to a stationary gyroscope radar, the radar will move in the direction of force. However, when the same force is applied to the rim of the spinning radar, the force causes the radar to move as though the force had been applied to a point 90 degrees around the rim in the direction of rotation. This turning moment or precision places the radar is a new plane of rotation which is parallel to the force. Precision is caused by both friction in the gyro and by aircraft maneuvering inclusive of turns, acceleration and deceleration. Precision cases a slow drift in the gyro and results is average readings. Cross-checking the heading indicator or directional gyro with the magnetic compass and making the appropriate corrections should be accomplished on a regular basis. Gyro power sources. Gyroscope instruments are generally powered either electrically or pneumatically. In the former case, the radar is incorporated as the armature of an electric motor, while in the latter, a vacuum pump driven by the engine reduces the pressure within the instrument case. Filtered air from the cabin is drawn into the instrument, acclaimed and directed at the radar wheel to case it to turn. Vacuum instruments are sub- susceptible to odor reading due to radar declaration should the vacuum pressure drop and are not suitable for high aptitude installations. Gyroscope effect. The gyroscope effect is most prominent on a tail wheel aircraft. When the tail is lifted off the ground, as the tail is lifted, the proper plane of rotation is changed. The force to change the PPO or is applied to the top of the propeller. There is resultant force due to positions will be experienced on the right side of the proper clockwise spinning proper. The force on the right side of the proper creates a yawning moment to the left. The magnitude of the gyroscope effect is directly proportional to the PPO or change force. The greater the rate of PPO or change, the greater the gyroscopic effect. This is the diagram of gyroscope effect on aeroplane taking turn. This is the aeroplane aerodynamics applications of aerodynamics in gyroscope. Thank you. This is